So I'm an intellectual historian whose research falls between the history of science and the philosophy of medicine. So I trace how scientific knowledge has changed over time, and I relate this back to concepts of disease and health. Among my many interests, I'm very interested in this concept of revolutionary change in science and medicine. So we know about the Copernican revolution in astronomy and the Newtonian revolution in physics, and we think about these as fundamental shifts in the scientific worldview of the time. And we also know about revolutionary breakthroughs in medicine, like the discovery of penicillin or the use of streptomycin. And these have saved countless lives. The trouble is, these days, we hear about revolutions in science and medicine nearly every day. So how do we distinguish the real revolutions from clever advertising? So my research question began life with one of these revolutions. In the 1980s, psychiatrists in the USA and the UK claimed that there was a biological revolution taking place within psychiatry. They argued that recent scientific research had shown that mental disorders were in fact brain disorders, and that all mental illnesses would, in principle, be shown to be abnormalities of neurotransmission. As one psychiatrist put it in a popular book, a mental disorder is the result of a broken brain. What was this biological revolution in psychiatry? Was this a fundamental shift in worldview, or was this clever advertising? So, in order to investigate further, I focused on one part of this revolution, which was the use of brain imaging. And I asked, how has brain imaging changed our scientific understanding of schizophrenia, one of the most severe psychiatric disorders? So, in order to answer this question, I looked at how the earliest form of computer-assisted brain imaging, called CAT scanning, was used by psychiatrists to study patients with a diagnosis of schizophrenia from the 1970s to the 1990s. As a historian, I use three different methods to reconstruct past events. I use archival sources, so the documentation left behind by big administrations. I look at published material from the time, so texts like newspapers and scientific journals, but also film and video. And I conduct research interviews with psychiatrists and scientists talking about their past careers. Over a period of 4 years, I reconstructed how a small unit for biological psychiatry in Britain used CAT scanning to develop a highly influential theory of schizophrenia as a brain disease. I traced how this theory spread across the research field and was reported upon in the mass media as a revolutionary event. And I also traced how, as the CAT scanner market exploded in the 1970s and 1980s, this kind of research spread across the world, from the UK to the USA, to Germany, Japan, and to Italy. As this kind of research spread, the finding that was first made in the 1970s in the UK was more or less replicated. This was the finding that patients with a diagnosis of schizophrenia seemed to have larger lateral cerebral ventricles than normal control subjects. So I found that behind the story of a revolutionary technology leading to a breakthrough in our scientific understanding of schizophrenia, there was in fact a much more complex and non-linear process. Firstly, this key finding of enlarged lateral cerebral ventricles turned out to not actually be a new finding at all. There had in fact been earlier studies using an earlier form of brain imaging called pneumoencephalography, which had been conducted in the interwar period in Germany and then later also in Scandinavia and Japan. And by and large, they'd found similar results. So these studies had essentially been forgotten or discredited in Britain and the USA. Secondly, I found that this key finding of enlarged ventricles is still in fact very controversial within the research field. And it's not clear whether it's a feature of the disorder itself, so an indicator of a disease process, or whether it's in fact the result of long-term treatment with antipsychotic drugs. And finally, while this finding is persuasive that there's a neurological component to schizophrenia, the interpretation of this finding has radically changed since it was rediscovered in the 1970s. So through the 1980s, psychiatrists hoped that brain imaging would provide a biomarker for schizophrenia. That means you could diagnose people with the illness using brain imaging, or at least identify a subgroup. However, by the 1990s, it became clear that ventricular enlargement was not diagnostic for schizophrenia. You couldn't distinguish a person with the illness from someone without it by looking for enlargement. In fact, what they had shown in the 1990s was that it's only on average in comparing groups of patients and groups of normal controls that you start to see a difference. So my findings suggest that we should be fairly skeptical of the revolutionary claims made by biological psychiatrists in the 1980s. While there have been substantial advances in biological research into mental illness, these haven't translated into benefits for patients. My findings also relate to an old debate within the history of science. This is between internalist and externalist explanations of scientific change. So internalist approaches typically focus on factors to do with the scientists themselves. So new theories, new methods, and new techniques. While externalist approaches typically emphasize the social, political, and economic context within which science takes place. Now, my study contributes to a large body of historical research, which suggests that when we analyze revolutionary change in science, we should look more to external factors than internal factors. Revolutionary stories do not just passively describe how scientists work. Rather, they actively locate and legitimize that research within a specific social context. The very idea of a biological revolution in post-war psychiatry has less to do with fundamental scientific change and much more to do with psychiatrists presenting themselves as part of the biomedical establishment. So one of the findings that I highlighted has to do with the fact that while mental disorders are things that happen to individual people, biomedical research has by and large given us results at the level of groups or populations. And in fact, if we look across the biomedical sciences over the 20th century, we find that there has been a broad transition from thinking about disease as a discrete entity with a single cause, to thinking about disease as a continuous entity spread across a continuum with perhaps multiple causes. This transition has clearly got big implications for how we think about tests for disease and how we think about treatments for disease. And in order to understand this transition better, I'm working with the Biomedical Sciences Max-Planck Research Group here at the MPI to trace exactly how this transition took place in practice, how it's changed our approach to testing and treating disease, and how it's changed the kind of stories we can tell about scientific progress in medicine.